Welcome back, ladies and gentlemen, to the next page in the final review packet for Integrated Math 2. We're going to look at some factoring, and at this point we should be pretty comfortable with the idea of factoring. If I'm going to factor this expression here, again, I'm going to look for two numbers that just simply multiply to 15, right? Now, if I go for this, now you can use the diamond or the area model if you want to. Some of you guys might find it faster just to kind of plow through this thing. I know that the 2x squared is going to blast into a 2x and an x. Because my signs are negative positive, that should let me know that the signs on the inside of the bubbles are going to be negative negative. And from here, I just need to figure out two numbers that multiply to 15. So remember, the placement of the order, the placement of the numbers matters. So I think 3 and 5 is going to be my ticket. And remember, I want to put them in the right order, right? And if I need to check, I'll go ahead and check. How do I do that? I'm going to go ahead and draw an arc right here for my outer multiplication. Well, what does that get me? That gets me 10x negative. If I multiply these guys together, I get negative 3x. Can those combine out to become negative 13x? Yes, they do. So this is awesome. We have factored it. And then the next one, 57. If you attempt to factor it off the cuff, you will absolutely get it wrong. Because one of the things I want you guys to pay attention to in these is the fact that all three terms have an x, which means you need to go back to a basic move that you may have forgotten, and that is GCF. If I factor out the x, I'm going to say 3x squared plus 17x minus 6. Okay? Now, I want to make a special note of this. Because this is an expression and not an equation, I'm not going to divide everything by x because there's nothing on the right side for me to divide it by. So, unlike the equations where we solve by factoring, this x will remain in the finalized answer. So just make sure we're keeping that in mind. An expression and an equation are different. So this one will have the x remaining behind. An equation, we might be able to divide by a coefficient or whatnot. So just keep that in mind, guys. How does a 3x squared break up? 3x and x. Because this last sign is negative, I'm going to refrain from putting my signs in. If I wanted to look at numbers that multiply to 6, there's 2 and 3, there's 6 and 1. Because this number is 17, my gut tells me that 1 will go here and 6 will go here. Now, why did it tell me that? It's because I know that 3 times 6 will get me 18x, and 1, sorry, that is in fact a 1 and an x will get me a solitary x. So, how does this help me? If 18 was positive and x was negative, that would get me the positive 17 that I'm looking for, which means the plus goes here, the minus goes here, and there really is nothing else I can do with this problem. So, consider this thing fully factored at x parentheses 3x minus 1 and x plus 6. So, this is our final factor. Good job. Thank you. So, we're on the next section here. Speaking of our good old buddy GCF, he is making his triumphant return in problem 64. 2x squared minus 18 equals 0. It almost looks like it should be a difference of squares. But how do I make it so? Well, I'm going to go ahead and factor out a 2. Now, I could have done something a little bit different. It's not a big deal. There's multiple ways to solve this thing. Since this equals 0, again, I'm solving for x. It's an equation. I can actually divide out that 2. And I can do that because 2 is a constant. Now, that's different than another problem that you guys are going to see later on. If I factored out an x from this, I would not be able to factor out an divide by an x because x is a variable and I need to keep it there. So don't do that. I can only divide out the 2 because he's a constant, he's a number. His impact will not be significant or actually matter at all in this problem. So here we go. Here's x squared minus 9 equals 0. Because I'm in a factoring kind of mood, I will go ahead and solve this by factoring. Again, you could have added 9 to both sides and then taken the square root. It's not a big deal. As long as you remember when taking the square root, you get the plus or minus. That will happen organically here in this problem where you have x minus 3 equaling 0 and x plus 3 equaling 0. So from here you get x equals 3 and x equals negative 3. And that is how you solve this quadratic equation by factoring. Again, biggest thing, I can divide by the 2 now and get rid of it entirely because it's an equation set equal to 0, unlike the last problems which were an expression, there's nothing on the right side to divide it by. I just have to keep the 2 there already factored out. So that's a big thing to keep in mind. Please don't make that mistake on the final should you see this problem. Moving on to 66. Now, this problem here is under the heading of solve the quadratics by factoring, which makes me believe this is factorable. But even if it didn't say that, even if it didn't say factoring, which it will likely not on the final, your first weapon of choice should be factoring. So how do I get this thing to be factorable? Here's what I don't do. I do not factor out an x and then set both of them equal to 4. I don't do that. That's not good. That's very, very bad. Okay, I'll even make him angry. Okay, I don't do that. Instead, what you do is you set this equation equal to 0 by subtracting the 4 from either side. And now you have a situation to where it's possibly factorable. Let's see how this thing would roll out if we were to factor it. So, 2x and x, thank goodness for small favors and this being a prime number. Two numbers that multiply to 4. Okay, check it out. I could do 2 and 2, because that certainly does equal 4. Here's why it's absolutely wrong. Because if I do 2 and 2 here, that means that there's a GCF in this left side factor here. And if there was a GCF in this left side factor, that means that there should have been a GCF in the problem when it was initially started. But if you look at this quadratic right here, there is no GCF to speak of, which means if there's no GCF here, there is no way there could ever be a GCF here. So keep that in mind if you are going to attempt to guess and check. The idea of GCF definitely helps with choosing your numbers appropriately. So it looks like 2 and 2 is out of the question. 4 and 1 is in the question. Now, again, for the same reason I spoke about just a few seconds ago, 4 and 1 would not go in that order because of the whole GCF thing I talked about a few seconds ago. So if you want to experience deja vu, just rewind and hear me talk about it again. That leaves the only option of 1 and 4 being my options. I want this 7 to be positive, so I'm going to make the 4 positive. Why? It's because when I multiply those guys, I get 8x. If I subtract this 1, I'll get a negative 1x, which gets me to a positive 7. Now, I am not done with this problem yet. This is not a simply factoring problem. I have to then set up 2x minus 1 is equal to 0, and x plus 4 equal to 0, unless you think you can do these in your head, in which case go for it. But if you make a mistake, I will dock you for not setting them equal to 0 also. X then equals 1/2, and x then equals negative 4. So, relatively easy problems, but there's nuances. So just make sure you guys are aware of the nuances so that you can maximize the number of points you get on our final coming up for you next week. And here we are on the next section, solve the quadratics by completing the square. Again, I would not be dependent on the queue up of this problem. On the final, it is very likely we're just going to say solve this, and it's going to be your job to figure out which one you're going to use. Now, how do I know completing the square is a very good method for this problem? It's because I have a reasonable suspicion that this is not factorable. I can't think of two numbers that multiply to 8 and add to 10 at the same time, and I'm thinking real hard. I can't think of anything. But I guess I'll find out when I do completing the square. Because this b term is even, meaning this number in the middle, which is b, which is 10, is even, completing the square lends itself pretty nicely to this problem. The way I initiate completing the square is I'm going to go ahead and subtract 8 from both sides, so I just get 8 out of here to the right side. And now I'm going to add the box on either side. And the box is going to be squared, and the number that goes inside the box is, in fact, 5. Great job. So, how does that help me? Visually, it helps me see that this is really x squared plus 10x plus 25, but because I did not square, I put in this number pre-squared, it allows me to visually see that it will simply turn into an x plus 5 squared. Again, what did I do? I just took one number from each extreme and I put it in there. This is going to require a little bit more work. So what is 5 squared? It's 25. 25 minus 8 is, in fact, 17. And then from here, I am going to square root both sides. And because the square root of 17 is not a clear-cut number, I'll go ahead and leave him as plus or minus rad 17. And then from here, I'll go ahead and just subtract 5 from both sides to get x by itself. X equals negative 5 plus or minus rad 17. That is to say, if you felt so compelled to split your answer, negative 5 plus rad 17 and negative 5 minus rad 17. Now, the fact that a rad 17 is a part of our answer is just an affirmation that this was not factorable. Right? If you attempt to do completing the score on a quadratic and you end up with like 7 or negative 3 or 1/3 or 2 or anything that doesn't have a radical or an I in it, that means that your original quadratic was in fact factorable. So just keep that in mind, guys, as you guys move forward. Anyway. Moving on to 71. This is already preloaded for completing the square. Now, if it was up to me and I was given any tool I wanted, I would actually use the quadratic formula on this because this b term in the middle is actually negative. So here's what I would do. I would do x squared plus 3x minus 20 equals 0 and then go quadratic formula on it. I believe that would make my life easier. However, because the problem asked me politely to do completing the square, I'll go ahead and indulge them and do completing the square because it's also good practice for us to mess with odd numbers in completing the square anyway. So what am I going to do? I'm going to go ahead and add the box on either side. Add the box. Now, I drew the box this way because the half of 3 is literally 3 over 2. And now this is again why I do it this way. It's because the easy side then factors into x plus 3 over 2 all squared is equal to, this is going to be some hard stuff here, 3 over 2 squared is 9 over 4. Now, I'm going to go ahead and call 20 80 over 4. Now, I did that because it allows me to find a common denominator so I can successfully add these two fractions together. So what do I get on the right side? I get 89 over 4 is equal to x plus 3 halves all squared. From here, square roots on either side. So what I get is I get x plus 3 halves is equal to square rooting these guys individually gives me root 89 over root 4 is 2. Don't forget the plus or minus. And if I just subtract 3 halves from either side, I will get x equals negative 3 halves plus or minus rad 89 over 2. If you felt so inclined, you could actually put them over the same denominator and say x equals negative 3 plus or minus root 89 over 2, which is exactly what you would get if you did the quadratic formula, meaning negative 3 plus root 89 all over 2, negative 3 minus root 89, sorry, that's not an 82, 89, all over 2. So, long story long, completing the square is used on that one because they asked me to. Having said that, I believe the quadratic formula is a better tool for 71, but that is a style point that is entirely up to you. See you in the next section. Speaking of our old friend, the quadratic formula, here it is in this section. So, what is the quadratic formula? Well, it is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright? So, we just have to apply this plugging and chugging mumbo jumbo into this formula here. So, what's a? A is 1. What's b? B is 3. And what's c? Be careful, c is in fact negative 5, not 5. So, how do I apply this into this formula? Well, I always do this. X equals negative thing plus or minus the square root of a thing squared, that is too small, a thing squared minus 4 times 2 things all over 2 times a thing. So, the question is what goes inside said things. Well, I'm thinking a 3 and a 3 goes in there. I'm thinking next to the 4 goes a 1 and a negative 5. and next to the 2 goes a 1. So from here, it's just a bunch of arithmetic. So from here, negative 3 becomes negative 3, plus or minus the square root of 3 squared, which is 9. Negative 4 times negative 5 is positive 20. Don't forget about that 1, but he doesn't really matter. All over 2. What does that get me? Negative 3 plus or minus root 29. No square root there, and thank goodness there's no way to simplify it. So we're pretty much at the end of this problem here. X equals negative 3. You could leave it like that if you wanted to, but if you really wanted to define yourself, negative 3 plus rad 29 over 2, or negative 3 minus rad 29 over 2. Remember, there are 2 answers. So just make sure you guys keep that in mind. So that is the first problem. Here comes the second problem. And again, if you need me to slow down, or if you need our substitute teacher to rewind, go and ask her to rewind, and we will take a look at those problems again. It's not a big deal. That's the wonderful thing about YouTube. So A equals 2, B equals, be careful, it's negative 1, C equals 7. So, again, plugged in, X equals negative thing plus or minus the square root of a thing squared minus 4 times 2 things, all over 2 times a thing. So, what goes inside said things? Negative 1 goes in here, 4 times A, which is 2 this time, not 1, C, which is 7 this time, all over 2A, which is 2 times 2. So, again, arithmetic, which I don't want to make it sound too light. Arithmetic is very hard. We just got to move, happy and slow through this. 1, because negative 1, plus or minus the square root of negative 1 squared is 1. Unlike the last problem, this will actually turn into a negative number, right? Because it's negative times positive. So I'm looking at negative 8 times 7, which is minus 56, all over 4. So, kind of weird. 1 plus or minus rad negative 55 over 4. Now, 3 days ago, you could have said no solution because you're taking the square root of a negative value. That is no longer your reality, because we know that through our experiences being electrical engineers at Chuck E. Cheese, we can take the square roots of negative numbers and get imaginary numbers out of them. Luckily, 55 cannot be simplified, so all you have is x equals 1 plus or minus, pop out the I, because that is technically the square root of the negative 1, and then positive rad 55 over 4. So, congratulations, you electromagnetic, mechanical, technical service diagnostic engineers at Chuck E. Cheese. That is the answer to your quadratic equation.